What if I told you we've already sent robots to every major world in our solar system, and what they found completely rewrote the science textbooks? Ice volcanoes, underground oceans, winds that move faster than the speed of sound. So here's the question. What exactly did we discover on each planet? And which one revealed something so bizarre scientists still can't fully explain it? In the next few minutes, I'm going to walk you through every single planet we've explored, starting closest to the Sun and working our way out to the frozen edge of the solar system. Let's start with Mercury and the Messenger mission launched in 2004.
NASA's mission to Mercury.
Getting to Mercury is one of the hardest navigation problems in spaceflight. You are not just flying toward the Sun. You have to slow down, a lot. Messenger spent 7 years looping through the inner solar system, flying past Earth once, Venus twice, and Mercury itself 3 times. Each flyby shaved off just enough speed to let the spacecraft sink deeper into the Sun's gravity well. In 2011, Messenger finally entered orbit around Mercury, becoming the first probe to orbit Mercury long-term. Mercury experiences temperature swings from about 800 degrees Fahrenheit during the day to minus 290 degrees at night, the most extreme range of any planet in the solar system. And inside permanently shadowed craters near the poles, places that never see sunlight, Messenger discovered vast deposits of water ice. Water ice on the planet closest to the Sun. It sounds impossible, but it's real. Billions of tons of it just sitting in the shadows. Next up, Venus and the Magellan mission launched in 1989. From Earth, Magellan fell inward toward the Sun, then was captured by Venus's gravity. Instead of landing, it entered a long looping orbit around the planet, circling again and again for years. NASA's Magellan spacecraft used radar to peer through Venus's toxic clouds. What it revealed? A hellscape. Surface temperatures of 900 degrees Fahrenheit. Atmospheric pressure 90 times Earth's, like being about 3,000 feet underwater. And the surface is dominated by volcanoes, thousands of them, and active ones. Magellan mapped 98% of Venus's surface and showed us a world shaped by extreme volcanism. If you want a picture of what happens when a greenhouse effect goes completely out of control, Venus is it. All right, next stop. Mars and the Curiosity rover, launched in 2011. After leaving Earth, Curiosity cruised through space for about 8.5 months, carefully syncing its path with Mars as both planets moved around the Sun. Timing was everything. Arrive too early or too late, and Mars would simply miss you. In 2012, NASA landed Curiosity inside Gale Crater, using one of the most daring landings ever attempted, a flying crane lowering a 1-ton rover onto another planet.
Touchdown confirmed. We're safe on Mars.
Think about that. We didn't just land on Mars. We landed softly with pinpoint precision. Curiosity gave us daily weather reports from Mars, temperatures, winds, radiation levels, and how harsh the surface really is. But here's the big one. Curiosity was built to answer a deeper question. Could Mars ever have supported life? By drilling into ancient rocks, it found evidence of long-lasting lakes, organic molecules, and the chemical ingredients life needs. Not proof of life, but proof Mars was once habitable. What Curiosity proved is that Mars wasn't always a frozen desert. It was once active, wet, and potentially friendly to life. And that's exactly why we're still going back. Okay. We're leaving the rocky planets behind. From here on out, we're talking about worlds so massive, they make Earth look like a marble. Next up, Jupiter. 11 Earths could fit across its diameter. Over 1,300 Earths could fit inside it. For this one, we're going to talk about the Galileo mission, launched in 1989.
And the Galileo spacecraft bound for Jupiter.
Reaching Jupiter required a cosmic slingshot. Galileo flew past Venus once, Earth twice, and used each gravity assist to build enough speed to reach the giant planet. After a 6-year journey, Galileo arrived at Jupiter in 1995 and spent 8 years orbiting the giant. It even dropped a probe directly into Jupiter's atmosphere, the only time we've ever done that. So, what did Galileo find inside? Winds, up to about 330 miles per hour, and temperatures rising fast. The probe lasted 58 minutes before the pressure crushed it. But here's the real bombshell. Galileo flew past Jupiter's moon Europa and found strong evidence of a liquid water ocean beneath its icy shell. We're talking about an ocean potentially twice the volume of all Earth's oceans combined, hidden under miles of ice. That discovery changed everything, because where there's liquid water, there might be life. Now, on to Saturn. And of course, Cassini mission launched in 1997.
The Cassini spacecraft on a billion-mile trek to Saturn.
Cassini followed one of the most elegant trajectories ever flown, swinging past Venus twice, Earth once, and Jupiter once. Each flyby carefully reshaped its path outward. After nearly 7 years in space, Cassini entered orbit around Saturn in 2004. From 2004 to 2017, NASA's Cassini spacecraft orbited Saturn and delivered some of the most jaw-dropping discoveries in space exploration history. Those rings? Turns out they're incredibly dynamic, constantly changing, with particles ranging from tiny grains to chunks the size of houses. But Cassini's biggest find wasn't the rings. It was Enceladus, a moon only 310 miles across, about the distance from New York to Boston. Cassini flew through plumes of water vapor shooting out of cracks in the ice and found organic molecules and evidence of hydrothermal activity. Translation? This little moon has the ingredients for life right now. Oh, and Cassini also carried the Huygens probe, which landed on Titan, Saturn's largest moon. Titan has lakes and rivers of liquid methane. It rains there, not water, hydrocarbons. It's like an alien version of Earth's water cycle. Wild, right? Now, we're heading to the edge. The ice giants. Honestly, this part is kind of heartbreaking because we've only visited these worlds once. The only mission to visit Uranus and Neptune is Voyager 2, launched in 1977.
Of the Titan Centaur carrying the first of 2 Voyager spacecraft to...
Not on a direct path to any single planet, but into a rare cosmic alignment that happens only once every 176 years. After leaving Earth, Voyager 2 spent nearly 2 years coasting through deep space before reaching Jupiter in 1979. The flyby was brief, but crucial. Jupiter's gravity bent Voyager's path and flung it outward at a higher speed, setting up the rest of the mission. 2 years later, in 1981, Voyager 2 passed Saturn. That encounter acted like a cosmic steering wheel. Saturn's gravity redirected the spacecraft onto a trajectory no mission had ever taken before, toward the ice giants. In 1986, almost 9 years after launch, Voyager 2 reached Uranus, arriving at a world humanity had never seen up close. Here's the weird thing about Uranus. It's tilted almost completely on its side. Its axis is tilted 98 degrees. Nobody knows exactly why. Probably a massive ancient collision. Voyager discovered 10 new moons, revealed details of faint rings, and mapped a magnetic field that's wildly off-center and tilted, totally different from any other planet. One moon, Miranda, has some of the strangest terrain in the solar system. Cliffs up to 12 miles high. That's more than twice the depth of the Grand Canyon, just dropped on a moon 290 miles wide. 3 years later, in 1989, Voyager 2 reached Neptune, 2.8 billion miles from Earth. What it found was chaos. Neptune has the fastest winds in the solar system, over 1,200 miles per hour. That's supersonic. And nobody fully understands what drives them, because Neptune is so far from the Sun, it barely gets any heat. Voyager also gave us our first good look at Triton, Neptune's largest moon. And guess what? It has cryovolcanic plumes too, nitrogen gas shooting miles into the sky. Water-rich plumes on Enceladus, nitrogen-driven plumes on Triton. These icy moons are way more active than anyone expected. And now, Pluto. Okay, I know. Pluto isn't officially a planet anymore. I mean, how could it be? It's smaller than Australia. But hear me out, because what we found there might be the most surprising of all. The only mission to visit Pluto was NASA's New Horizons spacecraft, launched in 2006. New Horizons left Earth faster than any spacecraft before it. It used Jupiter as a final gravity assist, slinging itself toward the edge of the solar system. For 9.5 years, it coasted through deep space, covering 3 billion miles. Then, In 2015, it passed Pluto in a single fast flyby. Before that flyby, Pluto was basically a blurry dot. After, we saw mountains made of water ice, some 11,000 feet tall, nitrogen glaciers, a thin atmosphere with haze layers. And that heart-shaped feature on the surface? That's Sputnik Planitia, a massive nitrogen ice plain bigger than Texas. Pluto, a world 40 times farther from the Sun than Earth, was supposed to be dead. Instead, it turned out to be geologically active. So let's bring it all together. We've sent spacecraft to every major world in our solar system. And here's what we learned. Mercury has hidden ice. Venus is a volcanic nightmare. Mars may have had life. The jury's still out. Jupiter's moons have underground oceans. Saturn's tiny moon Enceladus has plumes loaded with organic molecules. Uranus spins on its side. Neptune's winds break the sound barrier. And Pluto, a world we almost ignored, turned out to be one of the most complex places we've ever seen. Here's what keeps scientists up at night. Europa and Enceladus have liquid water right now. If we're going to find life beyond Earth in our solar system, that's probably where it is. So here's my question for you. Drop it in the comments. Which world do you think we should go back to first?